Hi, I'm Mark Bosley. I'm the Business Support Divisional Manager. I think if you did an audit of the different types and grades of water used within the food and beverage industry, you'll find they're quite varied. Everything from tap water, borehole water, right through to ultra pure water. Then there's the middle ground of water that's used for steam generation. There are several areas of cost savings that can be made if you get your water quality correct. One area certainly is in the raising of steam, for example. Basically, you're boiling water to raise steam. In doing that, you can create scaling within a boiler. So to reduce the amount of scaling, we tend to soften or treat the water through reverse osmosis. This can reduce things such as, and these are where the hidden costs come in, things such as maintenance of the boiler, cleaning of the boiler, and obviously the fuel needed to raise the water to produce steam. They can be varied and a number from a very coarse things such as sand filtration, cartridge filtration for the removal of particulates, right up to a full-blown system which would involve filtration, softening, dechlorinisation, reverse osmosis. It all depends on your application and what you want to do with the water. Traditionally though, the water purification systems in this market area has been at the lower end, filtration and softening. But today, when we're looking at making cost savings with water recovery, for example, then we must look at reverse osmosis. Reverse osmosis is a technique that is in common practice today. It's been around for many years. It's a process that relies on the separation of impurities in water by passing water across a semi-permeable membrane. Semi-permeable membrane is designed such that it allows the passage of water and rejects impurities. The process is basically you feed water under pressure across the membrane and you remove from that water stream a percentage of the water as purified or pure water. The remaining water then basically washes away those impurities that have been rejected. It's a continuous process, it's a very efficient process. You can remove up to 98% of the dissolved minerals from the incoming feed. You can reject very high amounts of bacteria and pathogenic materials, for example. And of course, water with high in organics also very efficient at removing organic waste. If we consider just the raising of steam, steam requires purified water for preventing boilers from scaling. It also provides the ability for boilers to run at higher cycles of concentration. By providing water that is lower and lower in total dissolved solids, i.e. with the inclusion of reverse osmosis unit, you can increase the cycles on your boiler and also on your cooling towers. By increasing the number of cycles that you can run your boiler and cooling tower means you lessen the amount of water you blow down. And of course, by reducing blowdown, you're actually saving on energy because every time you blow down, you're bringing fresh cold water into a system. And for a boiler, you've got to reheat it up. So by increasing the cycles, you're actually saving on fuel. With reverse osmosis, as you know, there's a purified stream and there's a waste stream. And that's the manner of the process. Reverse osmosis, the waste stream can, however, be recovered and be put through a secondary reverse osmosis unit, for example, and the purified water from that stream can then either be fed back to the front end of the process or again could be used for boiler feed, for example. So it's a way of cutting down or increasing the number of times you can use your feed water by reusing it through a second RO. Every site is different. You have to take into consideration the incoming feed water, what the water is going to be used for, i.e. raising steam, etc. Is there a cost in terms of effluent costs on your specific site? So what we would tend to do is work with you, run projections on what cost savings you could see in terms of, let's say, reducing boiler blowdown or increasing the cycles on your cooling tower, for example. Looking at your cost of fuel, as we all know, the cost of heating oil, gas, etc. is going up exponentially, and that's maybe where we can help you see your cost reductions in fuel costs.